Okay, on to 9.5. 9.5, we're going to talk about series. What we're going to be able to do is we're going to be able to use we're going to be able to use sigma notation. Okay, that's a Greek letter. I'm sure those of you that are familiar with fraternities and sororities will recognize that Greek letter. We'll be able to find infinite sums, finite sums, all kinds of sums, lots of sums. Okay, summation notation. Okay, that is the sum of the terms of the sequence. This is how we denote it. Okay, notice your sigma. It's read the sum of a sub k from k equals 1 to n. N is the number of terms. Okay, so the sum of a finite infinite sequence. So a finite means there's a set number of terms. So there's 8 terms, there's 12 terms, there's 20 terms. There's a finite number. Okay, what you're going to do, okay, you're probably not going to want to use that long formula you see in that box. Okay? What you're going to want to do is you're going to hit your math button. Okay? Now you're going to choose option 0. Okay? And then use, instead of n, use x. For some reason, n, I can't figure out how to use n with the calculator, but x works. Okay? So, you'll be able to plug everything in that way. So I have a corner section of a stadium. It has 8 seats along the front row. Each successive row has 2 more seats than the row preceding it. If the top row has 24 seats, how many seats are in the entire section? Now, here's our issue. What do we know? We know that the first term in the sequence is 8. That's the first row. The last row has 24 seats. Now, I put a sub n because I don't know how many rows are there. Okay? That's what we're going to have to try to find that out. Now, the common difference, it says each successive row has 2 more seats. So the common difference is plus 2. Now, I need to find out how many rows there are. Okay? So what I'm going to use is I'm going to use the explicit formula. Now this is arithmetic. So a sub n equals a sub 1 plus n minus 1 times d. Now here's the thing. Let's plug in what we know. A sub n is 24. A sub 1 is 8. Now I don't know how many terms there are, but I do know the common difference is 2. So 24 equals 8 plus 2n minus 2, distribute the 2. Okay? Combine like terms, move stuff over. Okay? So you're going to wind up with 18 on the left side equals 2n. So n equals 9. So there's going to be 9 rows. This is the number of rows. Now, it says how many seats are there in the entire section. So I have a finite sequence. There's 9 terms. So when I write my summation, there's sigma. Okay? From n equals 1 to 9. Alright? Now, what goes in the parentheses? Well, whatever this was, so this was 2n plus 6. Okay? So, 2n plus 6. So in your calculator, hit the math button, option 0, use x instead of n, and plug in what they want you to plug in. Okay? What you're going to find out is that there are 144 seats. Now, guys, what you need to do is not just copy down what I wrote. You have to know how to plug into the calculator. Okay? So actually plug in this series, this sum, and figure it out for yourself. Yes, I know the right answer is 144. Okay? But you need to understand how to find 144. Okay? If you've got the sum of a finite geometric sequence. Okay? All right? So, now, again, we're going to use our sigma notation. I mean, here's the formula. That's fine. But when we get to this, we're going to use our calculator. Let me show you. It says find the sum of the geometric sequence, and then they give it to us. Okay? So what do we know? We know that a sub 1 is 4. We know that r, now the common ratio. How do you find the common ratio? You take the second term and you divide by the first term. Okay? So negative 4/3 divided by 4 is negative 1/3. That's the common ratio. All right? Now, a sub n, okay? A sub n is 4 times negative 1/3 to the 10th power. Okay, that's this term right here. That's the last term. Now, what does that mean? This 10 is really n minus 1. So what value of n minus 1 is 10? 11. So n is 11. There's 11 terms. So, here's our sigma. From n equals 1 to 11, because there's 11 terms. 4 times negative 1/3 to the n minus 1. So in your calculator, math button, option 0, plug in your information. Okay? Now it's going to be a lot easier to do in the 84s than in the TI-83s. The TI-83, we could talk about that in class and we can get that all figured out. But you can use a calculator to do this. Now, what do you get? You get approximately 3. It's 3.0000 and then a bunch of numbers. Round it to 3. Okay? Now, an infinite series. Now, an infinite series never ends. Okay? Infinite goes on and on and on forever. Okay? So, an infinite series, to find the sum of that, from n equals 1 to infinity, because the sequence never ends, you're just adding all the terms. So you're just adding forever and ever. Let's talk about what happens here. For each of the following series, find the first 5 terms of the sequence of partial sums. Which of the series appear to converge? Okay, so here's the deal. Okay, what we're going to do here, we're going to find the first 5 partial sums. Now, what does that mean? I'm going to add, well, first of all, I'm going to take the first term. Okay, that's the first partial sum. It's just the first term. The second partial sum is the sum of the first 2 terms. So that's 0.11. The third partial sum is the sum of all 3 numbers, the first 3 terms. So now I've got 0.111. The fourth partial sum is the sum of the first 4 terms. Okay? The fifth partial sum. Now they didn't give you the fifth term here, but I think you guys can figure it out. There's the fifth term. The fifth partial sum is the sum of the first 5 terms. Okay? Now, okay, this approaches, I can't spell, it approaches a limit of 0.1 repeating, right? You can just see, we're just keep adding ones forever and ever and ever. Now, what is 0.1 repeating? Okay, now you can figure out in your calculator 0.1 repeating as a fraction. Well, that fraction is 1/9. Okay, so the series converges, because remember, if the limit approaches a value, a number, that means the series converges. And it converges, that's my dryer, to a sum of 1/9. Okay? Part B. Now, my first 5 partial sums. 10 is the first term, so that's the first partial sum. Add the first two terms. There's your second. Add the first three terms. There's your third. Add the first four terms. Now, as you can see, the fifth term here is 50. So add the first five terms. Now, what's the limit? Okay. It just keeps increasing. All right? There's no cap. It's never going to approach anything. So this increases without bound. Meaning that the numbers are just going to get bigger and bigger and bigger, and there's nothing that's going to stop it. So it diverges. Because there's no limit. Okay? Part C. First term, 1. Add the first two terms, 0. Add the first three terms, 1. Add the first four terms, 0. Fifth term, I believe, is going to be plus 1. Add the first five terms, 1. What happens? Okay? These values oscillate. Remember we talked about that term? Oscillate means it just goes back and forth from 0 to 1. That means there's no limit. So it diverges. Okay? So that's how you can use partial sums to figure out whether the series converge or diverge. Okay. Sum of an infinite geometric series. Now, here's the key. The geometric series. Now, I don't understand. They got some weird things going on here. So let me kind of make this look better. Okay? So if there's an infinite number of terms, here's the geometric sequence. It converges if and only if the absolute value of the common ratio is less than 1. Okay? So if that happens, you are going to use the sum will be A over 1 minus R. Okay? Now A is the first term. Okay? R is the common ratio. Okay? Now, if the absolute value of the ratio is greater than 1, it diverges and you don't do anything. But if it's less than 1, you're going to do that sum. So example 4. Okay? So we have 4 different problems. All right? Now, what is the common ratio? Well, the common ratio is 0.75. So the absolute value of 0.75 is less than 1. So we do have a converge. All right? First term. Okay? First term. So in other words, let k equal 1. Okay, what happens? You get 3 times 0.75. Now, 1 minus 1 is 0. So your first term is 3. So, remember, A over 1 minus R. We get to use that now. So A is 3 over 1 minus, well, what was the common ratio? 0.75. Now, you do not use the absolute value. So there's a chance that R could be negative. Like in the next problem, it's going to be negative. Don't use the absolute value in the sum formula. So I get 3 divided by 0.25. So my sum is 12. Okay? Or it approaches 12. Part B. Okay? R is negative 4/5. So the absolute value of negative 4/5 is less than 1. Okay? The absolute value of negative 4/5 is 4/5. So it converges first term equals, well, instead of k, they have n. So let n be 1. Actually, no. Oh, because it says down here n equals 0. Okay, so we got to let n equal 0 because that's the first term. So the first term equals 1, negative 4/5 to the 0. Okay? Now, so that means we have 1 over 1 minus negative 4/5. Now you say, why negative 4/5? Because that's what r is. So it's 1 over 9/5. So our sum is 5/9. Okay? Now, in part C, pi over 2 is r. All right? Crap. All right. Part C. Okay? The absolute value of pi over 2 is greater than 1. Right? Pi is 3.14. Well, 3.14 divided by 2 is bigger than 1. So it diverges. And you're done. You don't have to do anything else. Part D. Now, in Part D, they don't give you the sigma. They just give you the sequence of terms. So r, to find r, take the second term and divide by the first term. So that's r is 1/2. So the absolute value of 1/2 is less than 1, so it converges. Okay. A is 1 because they already gave us the sequence. A is 1, so there's nothing to plug in. So my sum is 1 over 1 minus the common ratio, which is 1/2. So that's 1 divided by 1/2, which is 2. Okay? So that's how you do the geometric ones. All right, last one. Try to keep this under 20 minutes. I apologize for the long videos, but apparently I have to do a better job of explaining things in the video, and you need to do a better job of listening to my voice on the videos. We need to express 0.234 repeating equals 0.234, 234, in fraction form. Now this is how you do it. We are going to write this as 0.234 plus 0.000234. Okay, we're just putting zeros in front of each 234. Plus 0.000000324 plus ... Okay, which goes on forever. So what's A? The first term is 0.234. What's R? Well, R, you take 0.000234 and divide by 0.234. Take the second term, divide by the first. And you wind up with 0.001. Now, it says to put it in fraction form. Well, since 0.001 is less than 1, I can use the formula that I used before, A over 1 minus R. So A is 0.234, first term, over 1 minus 0.001. All right. Now, what you're going to want to do is you're going to get a decimal. Okay, you're going to divide 0.234 over 0.999. So you're going to divide that and you're going to get a decimal. Okay, so math button, option 1, I believe, and then hit enter twice. And you're going to come up with 26 over 111. So that fraction gets you 0.234 repeating. Okay, so that's how you can convert from a repeating decimal to a fraction. Just a shade under 20 minutes. Okay, so take the time, make sure you understand this, and we'll be okay, hopefully.